Hello, this is Mr. Flatness. Today our lesson is going to be on the greatest common factor. Our goal for today is to find the greatest common factor of two or more numbers. So we're going to start out by talking about this word factors again. And it's so important that you understand what factors are. I would write this down in your notes again. Factors are the groupings of numbers. So giving you an example, the number 8. I know that 1 times 8 is 8. I know that 8 times 1 is 8. I also have two more factors. 2 times 4 is 8, and 4 times 2 is 8. We call these factors because that's how I can take 8 different people, let's say, and split them up into different groups without having any groups left over. I can create a group where it is one group of 8. So let's say I'm going to use X's and they're going to be students. So I could literally have one group of 8. Okay, just like that. Or I could have 8 groups of just one person in each group. Everybody's working by themselves. Okay, I could also take the group of 8 kids and I can split them up into 2 groups. Well, if I did that, then I would have 2 groups of 4. So here's one group of 4 kids, and here's another group of 4 kids. And finally, I could have 4 groups of 2. So I can split them up like that. 2 people in each group. So that's what factors are. It's a way to take a number and find out how many groups that you can create with an equal amount of each person in each group, so that there are none left over. And if you notice, there aren't any more factors of 8, so therefore I couldn't take 8 people and split them up any other way unless I had a remainder. So that's very key here. You need to understand what factors are for you to proceed to the next level. So we have more vocabulary here for you to write down. A common factor then would be a whole number that is a factor of 2 or more non-zero whole numbers. So basically what we're saying is then I can take 2 numbers and find out if they have a common factor between them. The other thing that we can talk about is the greatest common factor, and that would be looking at 2, 3, 4 different numbers and listing all their factors and to try to determine if there a number that is a factor of each of those numbers and identifying what's the biggest of all common factors. So giving you an example, let's say I dealt with the factors of 4, 6, and 8. So I know that the factors of 4 are 1, 2, and 4, 1 times 4 and 2 times 2. I know the factors of 6 are 1, 2, 3, and 6. So we're talking about 1 times 6 and 2 times 3. And the factors of 8 we've already talked about. That would be 1, 2, 4, and 8. 1 times 8 and 2 times 4. So if I want to know what a common factor is, notice that I have 1 in every single case here. 4, 6, and 8, I have 1. So that would be a common factor. Notice I also have 2. So 2 is also a common factor. Notice there are no other numbers where you see them in every single example. So therefore the common factors of 4, 6, and 8 would be 1 or 2. So then if we were thinking about the greatest common factor of these numbers, that would be the biggest number that I see. So the biggest number that I see and the greatest common factor of the numbers 4, 6, and 8 is 2. So then we would say that the GCF, greatest common factor, would be 2. So how would I apply that? By saying, well, let's say I have 4 people, 6 people, and 8 different people. And I wanted to see, well, what's the biggest amount of groups I could split them into without having any left over? I could split each group up into 2s, and I wouldn't have anybody left over. Here's another example to write down in your notes. They're a little bit bigger numbers, so we can kind of work through. Again, I'm going to use factor rainbows or just listing all the factors of all these different numbers. Again, I'm going to utilize my knowledge about divisibility rules, and I'm also going to recall the information that I know about my basic facts to get all these down. So there's a lot that goes behind this skill. So again, knowing your basic facts is incredibly important. And then using those divisibility rules that I have shared with you previous to this is also important, because it helps you speed through the process and it helps you be more accurate. So for the factors of 24, utilizing my basic facts, I know that 1 times 24 is 24. I'm going to write them in pairs. 2 goes into 24 12 times. 3 times 8, and 4 times 6. And there aren't any more factors, as I'll try 5, and I know that 5 is not a factor of 24. Now I'll take care of 16. So the factors of 16 are 1 times 16, 2 times 8, and 4 times 4. And there aren't any more there. So now I have listed all the factors of both numbers. I have common factors now of 1, 2, 4, and 8. So those are all the common factors. So they have 4 common factors for 24 and 16. But here I'm interested in knowing, well, I want to know what the greatest common factor is. So looking at that, I can see that the greatest of all factors that I have here is the number 8. So the GCF of 24 and 16 would be 8. In this next example, I'm going to use the ladder method as a way to shorten up my work and make it smaller to write down on my paper so that I'm not listing out all the factors of both numbers. This process streamlines what you have to do, and listing all the factors, especially when you get to very, very large numbers, can be a difficult process. So if I use a ladder method and if I use my knowledge of prime factorizations, I can still come up with the greatest common factor. So here's what we need to do. We need to make our ladder first. So I'm going to make my ladder. I'm going to put in the 2 numbers. I'm going to put in 20 and 50, and then I'm going to create my ladder. And now I'm going to work with prime numbers again. I must select the prime numbers. So up here I'll write down 2 to try, 3, 5, 7, and 11. And we'll try those prime numbers. And what I need to do now is when I select a number, the prime number has to be a factor of both numbers inside of the ladder here. So when I look at 20 and I look at 50, I notice that they're both even. So I know that 2 would be a factor of both. I also know that they end in 0. So I know that 5 would be a factor of both. So I'm going to choose 5. And now I'm going to divide both numbers by 5. 20 divided by 5 is 4. 50 divided by 5 is 10. And I'm going to make my ladder again. So now I'm going to look at the numbers 4 and 10 and see if I can find a prime number that is a common factor of both. Both of these numbers are even, so I know that 2 is a factor of 4 and 10. So I'm going to try 2, and then I'm going to divide both numbers by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Looking at my next set of numbers, 2 and 5. I already know that 2 is prime. 5 is also prime. And so I would see, finally, if there's any other prime numbers that go both into 2 and 5. And there aren't any. So, because I am done now, there are no more prime numbers that are factors of my n numbers, then the numbers on the outside of the ladder are the numbers then that I'm going to work with. And so if there are more than one number, then I'm going to multiply those factors together. So I'm going to take 5 times 2, the numbers that are outside of the ladder, and I'm going to multiply them together. So 5 times 2 is 10. So therefore, now I have found the GCF. The GCF of 20 and 50 is 10. And then I would also clarify that by saying this. 10 is a factor of 20. 10 times 2 is 20. 10 is also a factor of 50. 10 times 5 is 50. So, and there is no number bigger than 10. That would be a factor of both 20 and 50. A final thing I'll point out would be if you go through the ladder method and you can only come up with one number outside of the ladder here, then that number is your GCF. Let's try another example. I want to find the GCF of 45 and 60. So I will put those two in my ladder, 45 and 60. And again, I want to choose prime numbers that are factors of 45 and 60. So again, I think about the numbers 2 and 3, 5, 7, 11. So I'll look at it using my divisibility rules. I always like to go back to them. So remember we wrote those in our notes earlier, so refer back to them. If you don't have them, can't find them, find someone who does and recopy them down. They are so important. The more you work with those rules, the more you'll start to remember them and have them memorized, just like your basic facts. So looking at this, I see 45 ends in a 5, 60 ends in a 0. So I am going to select 5 as the number I'm going to choose that's prime. 45 divided by 5 is 9. 60 divided by 5 is 12, which is a basic fact. Now I'm going to look at 9 and 12, and I know that 3 is a factor of both. 9 divided by 3 is 3. 12 divided by 3 is 4. Now looking at 3 and 4, I know that there is no factor that's prime other than the number 1, and 1 isn't prime anyway. But there's no factor that will work for 3 and 4, so therefore I know then that I'm done, and I'm going to work with the outside two numbers, 5 and 3. So to find the GCF, I'm going to take 5 times 3, and that's 15. So my GCF is 15. And again, in other words, 15 is the largest factor of these two numbers, 45 and 60. Here are two problems for you to try on your own. Press pause now, solve them, and then press play to see their solutions. Hopefully you came up with 5 and 16 for the GCFs of those two problems. The final concept I want to talk about would be the concept or term called relatively prime. And numbers are relatively prime when the GCF of the two numbers is 1. So here's some examples of numbers that would be relatively prime and not relatively prime. I would need to use my ladder method to find out all the prime factors. So I'm going to quickly shrink this down so I have room to work. So I'm going to try 28 and 45. I'm going to use my ladder method. So I'll think about my prime numbers 2. Well, when I look at these two numbers, first of all, I have an even and I have an odd. So the first thing when you think about numbers is that when you look at and think of even numbers, I cannot take an even number and multiply that by anything and get an odd. And what I mean by that is, let's take, for example, the number 2. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. If I continue on that pattern, there's no way I'm going to get an odd. That also works for 4. Think about the multiples of 4. 4, 8, 12, 16, 20. Anytime I take an even number and try to multiply that out, I'm never going to get an odd. Okay? So odd numbers will never have even factors. Okay? So, but, however, I can have an even number like 28, and that could have an odd factor. For example, 7 is a factor of 28. 7 is an odd number. So the only numbers I want to try here are odd numbers. That helps out a lot. It takes out half the numbers to think about. So, thinking about this, I'll get rid of that. So thinking about my prime odd numbers. So we've talked about 3, we've talked about 5, 7, 11, 13. Those are odd prime numbers that I could try. So the first factor that I see that's odd that works for 28 is 7. But 7 is not a factor of 45. Here I'm utilizing basic fact knowledge for that. Okay. The next prime number to try is 11. Well, now I'm getting to numbers that are not factors either. 11 is not a factor of 28, nor is it of 45. 13 is not a factor of either one of them. So when you look at that, it's pretty safe to think here and know then that there aren't any prime factors that are going to be a factor of both 28 and 45. So then the only factor to think about would be the number 1. 1 goes into 28 and 1 goes into 45. So therefore the GCF of these two numbers is 1. And when the GCF of 2 or more could be 3, 4, 5 different numbers over here, doesn't matter. But if their GCF is 1, then you would say that these two numbers are relatively prime. Okay. In our next example, then, are 48 and 72 relatively prime? Well, right away you can see that both numbers are even. So right away you should think, well, 2 is a factor of both. And the moment you know that, the moment you know then that they have more than just 1 as a factor, so then are 48 and 72 relatively prime? We would say no, 48 and 72 are not relatively prime. So, concept about relatively prime and not relatively prime. Now that you've been taught the skill of finding the greatest common factor of a bunch of numbers, now we can take that skill and apply it to real life. And so I'm going to use this concept of finding the GCF of numbers and apply it to the real world. You made 48 rye dinner rolls and 60 wheat dinner rolls for a family picnic. You want to make up plates of rolls to set on all the picnic tables that you put down. Each plate is to contain the same number of rye rolls and the same number of wheat rolls, and there are to be no rolls left over. What is the greatest number of plates that can be made? How many rye dinner rolls and wheat dinner rolls are there going to be on each plate? So there's my question. It's kind of a two-part question. The big thing that sticks out are the important facts of 48 and 60. And we want to know what's the greatest number of plates Well, that's a lot like the greatest common factor. So I'm going to take my knowledge of using the GCF, finding the GCF, to solve this problem. So I'm going to shrink this down so I have some room to write. So I'll start off. I know that first thing I want to do is find out the GCF of 48 and 60. I'm going to use the ladder method. So I'm thinking about the prime numbers again. My numbers that I choose on the outside have to be prime. They're both even, so I'm going to try 2. So half of 48 is 24, half of 60 is 30. I notice they're both even again, so I'm going to continue with 2. 24 divided by 2 is 12. 30 divided by 2 is 15. Now I have an even-odd combination, but I know then 3 is a factor of both. 12 divided by 3 is 4. 15 divided by 3 is 5. Now I'm down to a point where 4 and 5 do not have any common prime factors. So I know that the GCF of 48 and 60, I would need to multiply 2 times 2 times 3. And 2 times 2 times 3 are the numbers on the outside again. That's what I multiply together. And that would give me 12. So the greatest common factor is 12. Well, if that's the greatest common factor, that's the greatest number of plates I can make. Okay? I can create 12 total plates. That's how many plates I have. Now, the final step is well then, how many of each bun is going to be on each plate? So, what I need to do there is to think about the word each and know that each is a division kind of word. So if I have 12 plates and 48 total rolls, what I'm going to do then is I'm going to figure out, first of all, then for the rye, I'm going to take 48 divided by 12. Okay, 48 total rolls, 12 plates, so then 48 divided by 12 is 4. So that means there's going to be 4 rye rolls on each plate. Then I'll take the wheat. I know that there are 60 wheat buns total, and I want to split those buns onto 12 different plates. And I know that 60 divided by 12 is 5. So I know then that there's going to be 4 rye rolls on every plate and 5 wheat rolls on every plate. So all the plates will look identical. Okay, and I'll use up all of my 48 and 60. There won't be any left over. So a final thing we could say is well then how many rolls are on each plate? Well, if there's 4 rye rolls and 5 wheat rolls, then I know that there's a total of 9 total rolls on every plate. So that's taking your knowledge of finding the GCF of numbers and applying that to a real-world problem. Use your notes to come up with the answer for this particular question. What does it mean if two numbers are relatively prime? Share that with a neighbor and see if you come up with the same answer. That concludes our lesson on greatest common factors.